Hi, this is Dr. John Bergdorf. In this video, I'd like to do a quick example of how to solve a linear inequality that contains fractions, like this one you see right here. Now, the big idea that we're going to go with is simply that we're going to multiply both sides by the least common multiple of the denominators. That will have the effect of clearing the fractions, and it's a perfectly legal thing to do. It's what I often refer to as the principle of balance. If you perform a mathematical operation on the left side of an equation or inequality and do the exact same thing on the other side, then you will maintain the solutions. There's a little twist to that for inequalities, which I'll remind you of a little bit when we get into it. So what would be the least common multiple of these denominators here? We see that the fractions in this inequality have denominators of either 3 or 4, and the least common multiple of those two numbers is 12. So we're going to multiply both sides by 12. Let's see how that looks. So here's our inequality again, and I'm going to take it 2/3 x minus 1/3 greater than 3/4 x minus 3/4. I'm going to multiply the left side by 12, and I'm going to multiply the right side by 12. Because there's more than one term, I'll use the distributive law and distribute the 12 across both terms on the left. That will give me, let's think of the 12 as 12 over 1. 12 over 1 times 2/3 x minus 12 over 1 times 1/3. On the other side, again, distribute the 12 across both terms. We would have 3/4 x times 12 over 1 and 3/4 times 12 over 1. And what's cool about that is that factors in the denominator are going to divide out factors in the numerator and result in much simpler expressions. This 3, for example, here divides into the 12 4 times, just like this 3 divides into the 12 4 times. On the right side, the 4 divides into the 12 3 times in both places. What does that give me? Well, in the first fraction, the numerator now contains a 4 times 2, and the fact that the denominator is just a 1 means that we can leave that blank. We therefore have 8x, technically 8x over 1, but we don't need to write the 1. In the second fraction, nothing is left except the 4, so 8x minus 4. And on the right side, we have the 3 times the 3 times the x. That's 9x. And 3 times 3 is 9. So 8x minus 4 is greater than 9x minus 9. I copied that onto the next sheet. Continuing with our idea of balance, it would be great if we could have all x terms on one side of the equation and all non-x terms on the other side. That could be handled a couple ways. For inequalities, most people can relate to them better if the variables are gathered on the left side of the equation. Don't really know exactly why that is, but it somehow psychologically seems clearer. To accomplish that, I could subtract 9x from both sides of the inequality, like this. On the right side, the 9x minus the 9x would give me a 0. On the left side, combining like terms, 8x minus 9x is negative x. And then to get the constants together on the other side, I can now add a 4 to both sides. All that was left at this point was a negative 9, adding a 4. And the negative 4 and the plus 4 on the left give me a 0, so I have negative x is greater than negative 5. Now think of the negative x as negative 1 times x, so that to get the x completely by itself, I would need to divide both sides by negative 1. And here is the point that I really want to make. In an inequality, if you multiply or divide both sides by a negative number, the inequality will reverse. The inequality reverses. If you have a greater than, it will become a less than. So when I divide both sides by -1, this becomes x less than, and -5 over -1 would be a +5. So the original inequality is equivalent to the very simple statement that x is less than 5. Now finally, let's think about how we would represent that answer. One way to do so would be to draw a number line, and we would be looking for all values of x that are less than 5. So maybe I'll have my number line go slightly into the negative numbers, and just a little beyond the 5. All the values of x that are less than 5 would be all of these. 5 itself would not work. We usually communicate that by drawing an open circle at the 5, which gives the impression or the idea that we get all the way up to 5, but we don't actually include it. 4.99999 would be fine, but 5 would not. That's representing it on a number line. We could also write this in interval notation, which is basically a picture of the number line. This interval that I see on my number line reaches from -infinity up to 5. To communicate that we don't include the 5, we use a round parentheses. If we did want to include the 5, we'd use a square bracket like this, which I'm going to immediately erase so it doesn't cause any confusion. And either positive or negative infinity will always be joined by always be designated with a round parentheses. So not too hard, simple example. If you multiply both sides of the inequality by the least common multiple, an inequality that starts out looking quite challenging is actually not too bad.